Well, typical data models you might have heard of in the data analysis world is the snowflake schema or the star schema. In this course, I want to focus onto the star schema because the course in the end is about Power BI Desktop. Therefore, I do not want to dive too deep into the data schemas and how to model these, but the star schema is a pretty common model, especially if you're getting started with data analysis, and it's also a model which pretty well fits to our current data. More about that in a few minutes. Let's first understand the theoretical concept behind the star schema now. Regarding the star schema, you might have heard about two different table types: dim dimension tables and a fact table. Dim tables are always multiple tables. A fact table is a unique table in the star schema. Now, to understand the star schema, let's imagine that we have a shop, an online shop, for example. And in this shop, you have different information you might store when it comes to your products and to your customers. For example, you might have a products table, which contains information, well, about your products. Which products do you have? You also might have a customers table with information regarding your customers. You might have a table with the time, so basically storing the individual date of each single day, maybe also including the minutes and the hours. And you might have a sales point, which is not necessarily required in an online store, but you could also have some real stores. Therefore, this could be different locations where you sell your products. Now, at this point, these are four separate tables. But let's now imagine that a specific customer, so one table, buys a specific product, which would affect another table, at a specific time, third table, in a specific location, the sales point, so the fourth table. This means you have an operation which touches all these four tables. So what you're missing here is a table which connects these four dim tables, these four dimension tables here. And this is now our fact table, which contains the information about our sales. Because in the end, if a customer buys a product, well, the sale is the interesting thing. Now, as I said, dim tables are multiple tables. The fact table is the table in the middle, you could say, which connects all these dim tables with each other. Let's have a look at the fact table now in a bit more detail, because this fact table could contain this information. The last three bullet points show sales-specific information only available in this fact table. So the units sold, the total sales, and the total cost. But you also have the 4 bullet points containing different IDs. An ID is always a unique identifier, so a number, for example, which exists only once in a specific table. Now, where is the product ID coming from? Well, it's coming from the products table here. Because this product table, again, contains product-specific information, like the product type, the price per unit, or the cost per unit, but also this product ID. This means for each single product you have in your store, you have one unique ID. Well, and this ID is also available here in the sales table. And with that, we have a connection between our sales and products already. But we can enhance this. If we look at the customers table here, we can again see information related to the customer, like the first and second name, age, gender, and so on. But also this customer ID. Again, a unique identifier for each single customer we have, and this customer ID can also be found in our fact table. Therefore, we now connected our customers and sales, and we can also allocate a specific customer to a specific product he sold. Because if a specific ID bought a specific product, we can match these two with the corresponding IDs. Well, and this logic can be further enhanced. We can have this timetable, which contains the year, the quarter, and the month as single columns, but also one date ID column, so typically, well, the single date of a specific day, which is also available here in our sales table. And the same thing occurs for our sales point. Here we have some sales point specific information, continent, country, city, could also be the address to be more specific, and the region ID. Again, a unique identifier for each single store where we sell our product. And this sales point ID, or this region ID, is also available here in our fact table. And that's actually the core idea in a nutshell. You have detailed information on specific areas, products, customers, time, and sales point in dedicated tables. And in the core table, the fact table, you connect the information of these dedicated tables, and you have some core data, in our case, the total sales, for example, stored in this fact table. It's all about creating a schema which allows us to better structure our data to avoid redundant information. Because if you would store all the customers, products, time, and sales point related information in this one table in the center, well, this would bloat this table and make working with our data not very convenient. Now, as I said, I don't want to dive too deep into the star schema here, but the question you might ask yourself is, what does this have to do with our current project structure?